Hello all, so welcome to our course on Introduction to Agentic Workflow from Simplilearn. So before moving on to creating the agentic workflow, let's first understand what is AWS Bedrock. So AWS Bedrock is a fully managed AI service that helps developers build and use AI-powered applications without needing to worry about setting up or managing complex infrastructure. So it gives access to pre-trained AI models from top providers like Amazon, Anthropic, Claude, Meta, Mistral AI, etc. So with Bedrock, you can create chatbots, text generators, summarization tools, and other AI-driven features without needing to train models from scratch. It also lets you customize AI models using your own data, add guardrails to ensure your safe and appropriate responses, and connect knowledge bases so the AI can provide more accurate answers. So since Bedrock is part of AWS, it also works smoothly with other AWS services, making it easy to integrate AI into your existing applications. So whether you're working to automate customer support, generate content, or enhance decision making, Bedrock provides a simple and scalable way to bring AI into your business. So now let's talk about serverless agentic workflows. So as AI-driven automation continues to evolve, businesses require intelligent agents that can understand user queries, retrieve relevant information, and take meaningful actions. So Amazon Bedrock introduces serverless agentic workflows, enabling organizations to build AI-powered assistants that interact with users, fetch real-time data, and execute business tasks, all without managing infrastructure. So in a traditional AI chatbot, the system typically responds to queries based on predefined answers or static knowledge. However, with serverless agentic workflows in Amazon Bedrock, AI agents can dynamically retrieve information and trigger actions, making them significantly more powerful than basic chatbots. So now let's explore how these workflows function, their key components, and their real-world applications. So when a user interacts with an Amazon Bedrock agent, the following steps takes place. First one is user input processing. So the agent receives a query from the user, such as, I need to return a laptop I purchased last week, can you help me? And the foundation model processes the input, extracts key information, and decides the next step. And the next step is information retrieval from a knowledge base. So if additional details are needed, the agent queries a knowledge base to pull relevant information. And the third step is action execution via AWS Lambda. So if the agent needs to perform an action, it calls an AWS Lambda function to interact with backend systems. So the function retrieves the order details, verifies eligibility, and processes the return request, for example. And number 4 is generating and sending a response. So the agent gathers the information and constructs a natural language response for the user. And finally, the session continuity and follow-up. So if the user asks another question, the agent continues the conversation while maintaining context. So the entire workflow runs on AWS infrastructure, allowing businesses to deploy AI-powered assistants without worrying about managing servers, scaling resources, or handling background execution. So here are some of the key components of serverless agentic workflows. So number 1 is Amazon Bedrock agent. So the core AI assistant that interacts with users, understands their queries, and determines the best course of action. So it basically uses pre-trained foundation models from providers like Amazon, Mistral, etc. to process and generate response. And then it has foundation models. So these are large language models that power the agent's natural language processing capabilities. So the model helps the agent to understand questions, retrieve information, and generate responses. And then there are action groups. So action group define what the agent can do beyond answering questions. They allow the agent to execute functions, fetch data, and interact with APIs. So for example, retrieving customer orders from a database, processing refunds using an e-commerce system, or creating support tickets in a help desk platform. So each action group is mapped to an AWS Lambda function which handles the actual task execution. And then we have AWS Lambda for business logic execution. So since Bedrock agents are serverless, AWS Lambda is used to execute backend logic without managing infrastructure. So for example, a Lambda function can look up order history, verify eligibility, and initiate a return process. And another Lambda function can check support ticket statuses and provide updates. And fifth, we have knowledge bases for data retrieval. So a knowledge base helps an agent retrieve factual information from structured databases, FAQs, or documents. And then finally, we have guardrails for AI safety and compliance. So guardrails ensure the agent's responses remain safe, ethical, and appropriate by filtering out harmful, sensitive, or restricted content. So here are some of the real-world use cases of agentic workflows. So number 1 is for customer support automation. So a company can deploy a Bedrock-powered AI agent to handle customer service tasks like answering FAQs using a knowledge base, retrieving order details via an action group plus Lambda function, and initiating return requests and processing refunds automatically. It can also be used in IT help desk support. So an internal AI assistant can help employees troubleshoot technical issues such as checking server uptime using AWS Lambda, resetting passwords via an action group request, or submitting IT tickets automatically in support system. And it can also be used in HR virtual assistant. Like for example, a Bedrock agent can be used to assist employers with HR related queries like fetching leave balances, processing leave requests, or providing company policy details. So basically, serverless agentic workflows in Amazon Bedrock unlock a powerful, scalable, and cost-effective way to build AI-driven automation. So these workflows represent a significant step forward in AI-driven automation, like allowing organizations to deploy intelligent, action-oriented AI assistants that go beyond simple conversation. So now in the coming chapters, we will see how to create agent with Amazon Bedrock, how to connect with CRM and perform calculations, and how to read an FAQ manual and a short Amazon Bedrock console walkthrough. So let's get started. Okay, but before we start, in this course, we have used the Claude 3 Haiku model. This is one of the latest AI models, and here is a quick look at its pricing. For Claude 3 Haiku, the cost is $0.25 per 1 million input tokens and $1.25 per 1 million output tokens. So throughout this course, we'll be using Claude 3 Haiku as a primary AI model. So alright, let's proceed with the course. Hello all, welcome to our first chapter. So in this chapter, we are diving into Amazon Bedrock to build a simple cloud-based agent. You'll also learn how to invoke the agent and trace its workflow through traces, giving you a clear view of how it happens. So let's get started. The first step, just like in every chapter, is importing the Bottle3 library. So this is basically AWS official SDK for Python, which we'll be using throughout the chapters. But before we start, we have to set up an environment to run the code. So first, let's set up the environment. Import OS. I'll be explaining you everything shortly. ARM is equal to OS dot environ Bedrock agent role. So basically, this code will reset the environment and prepare the resources. So let's just run this. Okay, sorry, there is a syntax error. Let's fix that. Yes, as you can see, it is resetting the environment. So the agent reset process is completed, Lambda reset process is completed, Guardrail reset process is completed. We had discussed all these in the introduction chapter. So the environment is set. So now let's start working on it. As I already mentioned before, let's import the Bottle3. Import Bottle3. Now the next step is we have to create a client object. So basically we create a client object to interact with the different AWS services. So let's do that. So Bedrock agent is equal to Bottle3 dot client service name is Bedrock agent, and we'll also provide the region name. So region name is US West 2. Now next we'll use this client to connect to the AWS and set up our agent there. So for your information, this code is configuring in a cloud-based agent that operates at production scale, so it won't be running in our notebook right now. So let's get started. So let's start by creating the agent. So this is actually pretty straightforward. We'll be using the Bedrock agent client and calling the create agent function. So let's write the code. So first, we'll be using the Bedrock agent client and calling the create agent function. So now let's, pass the parameters. Let's set up the parameters. So the first thing is we need to give our agent a name. We should call it something. So one thing to keep in mind is this name isn't something that the agent itself will recognize. It's just for our reference. So for example, I will name this one as laptop customer support agent. So now let's move on to the other parameters. First things first, we need to give our agent a foundation model. So basically this means selecting a specific large language model from Amazon Bedrock, which will handle the language understanding for how agent operates. So we'll paste the model ID over here. So the foundation model is Anthropic Cloud 3 Haiku. So now there are multiple models available, and you can find the full list in the AWS documentation, which I'll be showing further chapters. So here we have set up with Anthropic's Cloud 3 Haiku. This is very small, fast and highly capable model. So the next step is we need to define the agent's behavior by providing it with instructions. Now these are also known as system prompts. So let's give the instruction. So we have given it the instruction that you are an advanced AI agent acting as a frontline customer support agent. So in this case, the agent is acting as an advanced AI assistant for the frontline customer support, especially for laptop businesses. Now that we have set up the model and instructions, there's just one more thing left for the configuration, that is the resource code. So predefined IAM role has already been created for us in this environment, and we are pulling in its ARN. ARN means Amazon resource name from an environment available. So basically this role defines the security permissions for our agent. Basically dictates which services the agent can access. So in this case, we are keeping the thing secure and minimal, following the principles of least privilege, meaning the agent only has access to necessary language model and nothing else. So let's set up that. And yes, we are good to go. As you can see, we have loaded this into a variable, create agent response. Let's just check it. Yes. So as you can see, our agent is ready, it is created. So now you might have noticed that we haven't assigned any tools yet. So in Amazon Bedrock, these are called actions and they belong to action groups. So for now, we have built a basic AI-powered laptop support agent, and the next step is learning how to invoke and interact with it. So let's see how to do that. So as you can see, our agent status right now is in creating state. We have the agent ID, we have the agent name. So basically what happens next is the agent moves to a state called not prepared. So basically this is the full process the agent goes through. First state is creating, where the agent is being set up, which is happening right now. Then the second state is not prepared, where it exists but isn't ready yet. And the third one is prepared, where it's ready to use. So once it's prepared, we can create an alias for it. Alias is like a stable version of the agent that we can use in production. So because it lets us control updates, instead of changing the agent directly, we can manage different versions and keep things stable. But before doing anything else, we need to wait until the agent reaches the not prepared state. And that's when we can move forward. So now let's go ahead and store the agent ID in a variable. So basically, I'm going to pull it from the response we created earlier, from the agent field, where the agent ID is located. So let's do that. So agent ID, this is the variable. Create agent response. Agent ID. So this is really going to be very useful for us. Now we have to set up a few helper functions here. So for example, they'll help us wait for certain processes like transitioning to the prepared state, so we don't have to handle everything manually. And since we are working on laptop customer support, these functions will make it easier to manage tasks like checking the laptop's warranty status, troubleshooting hardware issues, and guiding customers through software fixes. So first, let's import the helper function. So from helper, let's first write the helper function and then I will explain the code to you. So wait for agent status. agent ID is equal to agent ID. A target status is not prepared. So as you can see that the agent has reached the not prepared state, which is actually a good thing. That's exactly what we wanted. So it has basically transitioned from creating state to not prepared state. So now the next step is to prepare the code so it's ready to go. So let's do that. We want it to be in prepared state. So as you can see now the agent is preparing, agent stated is preparing. So we have used the Bedrock agent, which is the client, if you remember we set up earlier, and we have called the prepare agent function. So basically we need to tell it which agent we are working with. So we'll pass in the agent ID also. We have passed the agent ID, which we had already stored in a variable. And thus it has reached in the preparing state. Now our target is for prepared state. So let's just take this code. And our target status is prepared. Let's see. So as you can see, the agent has reached the prepared state. But if you have noticed, as I showed you, it did briefly show preparing before it switched to prepared state. Now, as I mentioned earlier, the next step is to create an alias. And that is because we want to invoke the agent and have a conversation with it. So since the agent that we created is now prepared, we can go ahead and set up the alias. So let's do that. So let's move on to creating an agent alias using our Bedrock agent. Let's do that. Create agent alias. Response Bedrock agent. Create agent alias. Yeah. So to do this, we need to provide a few key details. So first, we have to specify the agent ID so that the system knows which agent we are working with. Along with that, we need to assign a name to the alias. So this name can be anything. For simplicity, we'll just call it my agent alias. So let's do that. First, let's specify the agent ID. Then let's set the agent alias name. Which is my agent alias. So now once we have these details, we'll store the response from this operation in a variable, right? So this basically allows us to reference it later when we need it. So the process involves calling the create agent alias function, passing it both the agent ID and the alias name. So let's do that. For that, alias ID is equal to create agent alias response. We have given the, we have passed on the agent alias and agent alias ID. So now before executing this, there's an additional step to ensure that everything runs smoothly. So we need to extract the agent alias ID from the response and store it in a variable. So this is important because we'll use it to track the alias status. So to make sure that the alias is properly set up, we'll use a helper function that waits for the alias status to transition to prepared. So let's write the helper function also. Let's include the helper function also. So yes, this is the helper function. So we have already talked about helper functions earlier. So now let's execute the code and see what happens. So as you can see, everything is working as expected. The alias transitions into the prepared state, which is exactly what we were waiting for. Now that the alias is ready, we can actually start using the agent. So with prepared alias, the agent is now in a functional state, meaning that we can interact with it. So let's move on and see how to put it into use. So now to interact with the agent, we need to create a new client specifically for this purpose. So we'll be using Bot23 to initialize it. So let's create a new client as we have done earlier. As you can see, we have, specified the service name and we have specified the region. Then we have stored this client in a variable. So let's run this. Now that we are ready to move forward and actually invoke the agent. So for that, we have to write a few lines of code. So first you have to import UUID. So we'll be calling the invoke agent method for our Bedrock agent runtime client, which is essentially all that's needed to start a conversation with the agent. So let's write the code first and then I'll explain it to you. So as you can see, this is the message that I've given as a customer that, hello, I bought a laptop from your store yesterday. There is an issue with the display and I want to return it. So as you can see, we have specified which agent it is by giving the agent ID. Similarly, we also passed the agent alias ID, which we had saved earlier in the process. And finally, we gave the message also. So at this stage, the agent doesn't have any actions configured, meaning it won't actually be able to troubleshoot the issue. However, it should still generate a response based on whatever logic it has available. So in addition to the message that we have given, we also have given a session ID. We have to establish a session ID to maintain the conversation, right? So you might have experience chatting with a, customer support agent, and you might have noticed that, there's a session ID and there's a session for each and every conversation. So once you end the conversation, when you're starting a new conversation, it's separately a new session. So similarly here also, we need to establish a session ID to maintain the conversation. So we have generated a unique ID using Python's UUID module, and that's why we have imported UUID first. So basically this ensures that each session is uniquely identifiable and the conversation history will be stored in the cloud, so we don't have to manage it ourselves. So here we have kept end session false, which means this keeps the conversation active instead of losing it after one exchange. And enable trace is true, which means this, and enable trace for now, let's keep it as false. Yeah, which means this disables request tracing for now, but we can explore it later. So let's just run this. Agent response. So as you can see, we have run the code over here. And as we print the response, you'll see that it doesn't display like a normal text response. And that's because it comes back as an event stream instead of a simple message. So since we can't just print it directly, we need to extract the actual response from the stream. So to do that, we'll pull the relevant data from the event stream, which will allow us to see what the agent actually said. So let's do that. Let's write a piece of code. Event stream is equal to invoke agent response completion. Event I event stream, just print event. So as you can see, when we do this, we'll see that there's only one main event returned, and this event is called chunk. And inside it, we have some data, specifically bytes and a response from the agent. So basically, the agent has responded that I'm sorry, but I'm unable to assist you with the return process for your laptop at this time. Please contact our customer support team directly and they will be able to help you with it. So this message makes sense because right now the agent doesn't have any action set up. It knows it's supposed to have some functions, but since we haven't defined any, it simply acknowledges its limitations. But how does the agent figure this out? And how does it do the necessary action? So for that, to get a clear picture, we have to enable the trace mode. So Earlier we have disabled the trace mode by keeping it false. So we have to enable it by making it true. So this will start a new session. It will reset everything and allow us to have another conversation with the agent. And this time with more insights into how it generates its response. So let's go ahead and do that. So as you can see here, I have enabled the trace and I've printed it. Here, as you can see, we can find some familiar details like they have given the agent ID, the session ID. They have given so many details. And I'm just finding the final response over here. As you can see, it has given a final response. To initiate the return process for your laptop with the display issue, please gather the following information: date of purchase, order number of receipt, description of issue. So as you can see, first it said that, I'm unable to help and please contact, some customer support agent, like, some human customer support. But as you can see now, it actually, gave us an answer that I want, some details like date of purchase, order number or receipt, etc., so that we can initiate the return process. So with this in place, we are now ready for the next step, which is adding actions to the agent so that it can actually perform some useful tasks. So we'll see that in the next chapter. So now that we have a basic agent set up and running, it's time to take things a step further. So in this chapter, we'll connect the agent to external services, allowing it to interact with the outside world. We'll simulate integrating it with a CRM system where it can retrieve customer details, log support tickets. So this will make our customer support agent more functional and bring it closer to real world use case. So let's see how it works. So first things first, let's set up the environment. Do that. So as you can see, the environment is being set up. This will take some time. Now next we need to import the required libraries. We'll start with module 3 to interact with AWS services. Import module 3. We also bring in UUID, which we discussed in the earlier chapter, which helps us create unique session IDs. And also we'll import some helper functions. So let's do that. Import UUID from helper. Import all. So since our environment variables are already set up, we're all set to go. So the agent from the last chapter, from the last environment, is still running. So we can continue using it. And this time we'll give more detailed instructions because we have added a few extra components. So now let's start testing and see how it works. So firstly, I'll generate a new session ID and set up another message similar to what we used in the previous chapter. Let's set up the session ID first. Session ID equal to and let's give a new message. For example, let's give my name as Via. My laptop has display issue and I want a refund. So once that's defined, we'll use a helper function to check the responses and see what happens. So we'll call invoke agent and use a print helper function to send a message and check responses. So let's do that. Invoke agent and print. Again, we have to specify our agent ID. Agent ID equal to agent ID. Input text is the message. That is one more thing. Agent alias ID is equal to agent alias ID session ID. So as you can see, this is what our response is. This actually looks like a chat format. They said that my name is Leah, my laptop has display issues and I want a refund. And the agent has responded by saying that it's sorry, but it doesn't have enough information to process our request for a refund at this time, and all the details. So now what we need to do is we need to connect our agent to some other tools to make it more useful. And in Amazon Bedrock agents, these tools are called actions and action groups. These allow the agent to perform tasks beyond just responding with text. So the logic behind these actions is handled through AWS Lambda functions. So basically the Lambda function serves as the invocation point where the agent sends requests when an action needs to be performed. So when the agent calls this function, passes an event that contains key details like agent's name, action group name, specific function, and any parameters. So let's do that now. Let's write the code first and then we'll explain. So to connect our agent with tools, we need to define an action group using the Bedrock agent client. So this action group will allow the agent to perform tasks by interacting with an AWS Lambda function. So first let's create the client like before. So we have done that. The service name is Bedrock agent, region name. We're not specifying the region right now. Now next step is to set up the action group. So yeah, now let's see what the code is. So we have started by naming the action group. The action group name is customer support actions, and this is just for our reference. Now the next thing is we link it to our agent by providing the agent ID from our environment variables, and we specify the Lambda function that will handle the logic using the ARN. Now after that we have defined the actions. Like for example, inside the action group we define functions the agent can call. For example, the first one is customer ID lookup. So this function retrieves a customer ID based on details like email, name, or phone number, and the agent must send at least one of these details to proceed. Now the parameters are described in natural language so that the agent understands their purpose. Now the next function, the second function is send to support. So basically this function escalates the issue to a human support team. Like for example, if the agent that we created is not able to respond, so it will escalate the issue to a human support team. It requires both a customer ID and a support summary, and if the agent doesn't have a customer ID, it will first fetch it using the customer ID lookup function. So this is what these two functions does. Now before sending the request, we have specified the agent version as draft. It means that it applies to the current agent setup. So once everything is set up, we have created the create agent action group response. This is a variable, create agent action group response, and we have stored the response in this variable. So let's look at the output. Create agent action group response. So as you can see, we have executed the request and we have our response. So this includes an action group ID. It has the action group state, which is enabled. And before we proceed further, we need to ensure that the action group is fully enabled. So although it's already enabled, as you can see in this case, we'll add a helper function to wait for the state. So this will ensure that, if we run the entire script from top to bottom, everything works smoothly without any timing issues. So let's add that helper code. Let's do that. So first we need to extract the action group ID. That's what we have done here. We have to extract the action group ID from the response, which will allow us to reference it later. Next, we'll give our helper function, like how we have given helper functions before. As you can see, the target status that we want is enabled. So now that we have made a change to the agent, we also need to prepare the agent again to apply the updates and update the alias so it reflects the latest version. So let's do that. Again, we'll be using helper functions for that. It's enabled. Now we, want it in the prepared state. Agent is prepared, and next is we have to update the alias. So let's do that. So the agent alias has also reached the prepared state. So basically we have, as you can see here, we have used the prepare agent function. So now the alias is fully updated and the agent is ready to use. So now, we can start performing tasks and we can just test it by giving a message. So again, first, before giving the message, we are going to reset the session ID. So let's reset the session ID and let's give a different message, including an email address. So my name is Leah, and we'll just give a dummy email ID like Leah at leah.com. My laptop has display issues. And I want a refund. So this time I've also included, as you can see, the email address. Now the thing is, with this email, the agent can confidently match it to the customer ID. So in this case, it will just be a random number, of course. So this helps simulate a real customer support interaction. So now let's run and see what happens. So first I'll give a helper function and call invoke agent to send the message and print the response. So firstly, we'll just write the helper function. Invoke agent and print. We'll pass on the agent ID. Agent alias ID. Just copy paste it because we have already used this function before. And right now we have kept the enable trace as false. So as you can see, it has given the chat, the user, a query and the agent response. So it has said, hello Leah, I'm sorry to hear you are having issues with your laptop display. So to better assist you, could you please provide some more details about the specific problem you're experiencing? So right now, as we gave the email, it might have already got the customer ID. So now it's asking about more issues. Like what's the specific problem you are finding and what is the, purchase date and everything. And also at the end, it has asked that please let me know and I'll help you to escalate this to our customer support team if needed. So this is what our agent has responded with. Now let's just keep the enable trace as true and see what happens. So as you can see here, you can see the user query, the final response, and the thing is you can also see the agent's thought process. So this is basically thought process that's going on with the agent, which means, okay, let me give you the details we have so far. It has taken the customer name, customer email, the issue, the request. Issue is that the laptop has display issues. The request is that, we want a refund. And it has processed that it still misses some key details to fully process the refund, such as order number or purchase date of the laptop. So without these details, I won't be able to properly escalate this to the support team. So let me ask the user about it, and that's what it has done over here. So as you can see, so far we have built an agent that responds effectively and uses tools to process customer support cases. It can retrieve a customer ID and log a support request, making it much more functional. This chapter will be seeing what are guardrails in AWS Bedrock. Hello, also in this chapter we will talk about what are guardrails in Amazon Bedrock. So what are guardrails? So basically guardrails in Amazon Bedrock are a set of safety measures that help ensure AI generated responses are safe, ethical and appropriate. Act as filters and restrictions that prevent the AI agent from generating harmful, biased or restricted content. So guardrails are essential for regulating AI behavior, especially in customer support, healthcare, finance, and other sensitive domains, where AI-generated responses must adhere to compliance standards. So now let's see how the guardrails work. So when an AI model generates a response, guardrails analyze the output before sending it to the user. If the response contains restricted, offensive, or policy-violating content, the guardrails block or modify the response. So the guardrails in Amazon Bedrock can be customized based on business requirements. So users can define content filters to block inappropriate language, deny topics that the AI cannot discuss, and harmful category filters to prevent responses related to violence, hate speech, self-harm, or explicit content. So these itself are some of the key features of guardrails. In content filters means it can filter and scan AI responses for profanity, hate speech, or offensive content and block them before they reach the user. In denied topics, predefined topics that the AI is not allowed to discuss. Example, political opinions, personal health advice, financial investment recommendations, etc. And then comes harmful categories, where adjustable safety settings for restricting responses related to hate speech, self-harm, violence, harassment, and adult content. And then it has custom word filtering, where users can define a list of restricted words or phrases that the AI should not generate in its responses. And then we have custom guardrails via AWS Lambda for advanced use cases. Custom logic can be implemented by using AWS Lambda to validate and modify AI responses dynamically. So now let's see how we can implement guardrails in Amazon Bedrock with some code examples. So there are basically 4 steps. So the first step is to create a guardrail. So this is the code for that. So to create a guardrail in Amazon Bedrock, you have to use the AWS SDK, which is Boto3 for Python, to define the content filtering, restricted topics, and sensitivity levels. So basically, this code creates a guardrail named Customer Support Guardrail, as you can see. And it filters harmful language, it blocks specific words, example, fraud, scam, illegal. It restricts discussions on specific topics like politics, religion, and investments, and it applies different safety levels to content categories. Now the next step is to associate guardrail with an AI agent. So once a guardrail is created, it needs to be attached to an Amazon Bedrock agent to enforce content filtering in AI responses. So this step ensures that the AI agent follows the guardrail rules and does not generate restricted content. And next we have testing guardrails by invoking the AI agent. So we can test if the guardrail works by sending a sample query to the agent and check its response. So as you can see in this code, if the guardrail is applied correctly, the AI agent will refuse to provide investment advice and respond with a safe and predefined answer, such as, I'm sorry, but I cannot provide financial investment advice. And finally, we have step 4, which is fine-tuning guardrails. So if the AI agent still provides undesired responses, you can adjust the guardrail by modifying the sensitivity levels or adding new denied topics. So in this code, the AI agent will not respond to financial or medical related queries, ensuring compliance with regulations. So now, why are guardrails so important? Number 1, to prevent AI misuse. So guardrails restrict AI generated responses, preventing harmful, biased, or unethical replies. Next is to ensure regulatory compliance. So industries like finance, healthcare, and legal services must comply with strict rules. So guardrails help prevent AI from providing unauthorized advice. And then to enhance customer trust. So a well-configured AI assistant maintains brand integrity by ensuring all the responses align with company policies and ethical guidelines. And finally, to reduce AI risks. So guardrails act as a safety net, reducing the risk of AI-generated misinformations, hate speech, or offensive content. So basically, guardrails in Amazon Bedrock are a critical feature for ensuring AI models generate safe, ethical, and policy-compliant responses. By implementing content filters, denied topics, and harmful category restrictions, businesses can control AI-generated output and protect user interactions. And by using AWS Lambda and customizable filters, developers can further fine-tune guardrails based on business needs, whether it's preventing AI from giving financial advisors, blocking offensive language, or ensuring customer support consistency. Guardrails help maintain AI reliability and trustworthiness in real-world applications. So that was it about guardrails. Now in the next chapter, we'll take it a step further by making the agent smarter. So instead of immediately forwarding requests to support, it will perform calculations before sending them. So let's get into it and enhance its decision making. All, welcome to the next chapter where we are going to give our agent a code interpreter. So this means the agent will be able to perform accurate calculations by writing and running temporary Python code to support its responses. So let's dive in and see how it works. And before that, as we mentioned in all the chapters, let's run the code to set up our environment. So let's do that first. Let's set up the environment. So first, I'll load all the necessary libraries. Same as before, we need the bottom 3. We need UUID, and we need to import the helper functions. So once that's done, the next step is to create a client, a Bedrock agent client. Same as before, so let's do that. Done. So right now the agent in our environment is the same that we used in the last chapter. So to enhance its capabilities, we'll update it and integrate the Amazon Bedrock agent with new features. So let's write the code. So let's see what this code is. So this code basically updates an existing action group in Amazon Bedrock by modifying its function schema and adding a new function. So first we have the function called update agent action group. So this function is called to modify the agent's action group. So this ensures the agent can execute the necessary actions when handling customer support requests. And then we have set up the code parameters. As you can see here, we have the action group name, which is customer support action. So this names the action group. We have kept it same as before. The action group state is enabled. So since we are modifying the action group, we explicitly set its state to enabled. So by default, an action group is enabled upon creation, but when updating, we must manually specify the state to keep it active. And then we have given the action ID group, the action agent ID. And as you can see, the agent version is in draft. So this update applies to the draft version of the agent because Bedrock allows multiple agent versions. So changes are first applied in the draft state before being finalized. After that, we have the lambda function, ARN. So the agent will execute actions using a lambda function. So the lambda function ARN is stored in the lambda function ARN variable. Now after that, we have defined the function schema. So inside the function, as you can see, inside the function, we have 3 other functions. The first function is customer ID function. So this function helps the agent identify a customer based on the available details. So as you can see, this is the description just given. Get a customer ID, given available details. At least one parameter must be sent to the function. This is private information and must not be given to the user. So what this means is that the agent can look up a customer ID but must not share it with the user. So at least one parameter is required. It can be email. These are the parameters. It can be email, name, or phone number. And then you have the send to support. So if the agent cannot resolve the issue, it can pass the request to your human agent. And then we have a new function, an updated function, which is called purchase search. So here they have given the description that search for and get details of a purchase made. Details can be used for raising support requests. You can confirm you have this data. Like for example, I found the purchase, or I can't find the purchase, so and so. So basically the agent can search for purchases and confirm whether it found the record. So however, private information like order numbers must not be shared. And as you can see, these are the parameters given over here. The first parameter is the customer ID. The second parameter is the product description. And the third parameter is the purchase date. As you can see, the purchase date, the date of purchase should be in this format: year, month, and date format. So basically, this function helps the agent verify past purchases before escalating the case. Before escalating the case, the agent must verify that, if the query is real or not. So for that, this helps. So now once everything is set, we have stored it to this variable, which is update agent action group response. So basically running this agent ensures that it retains previous functions, adds the new function. As you can see, these customer ID and send to support function we had already used in the previous chapter. So the new function that we have added is a purchase search function. So let's run this. Now let's extract the action group ID from the update response. So let's extract the action group ID. So here the variable update agent action group response contains a response from the update agent action group function, which we used before. So the response has a nested structure where the action group ID is inside the action group. So this line retrieves the action group ID from the response and stores it in an action group ID, which is for later use. So action group is enabled, action group status is enabled. So now let's give it a different message. We can give something like first we'll give the email, and then we'll say I bought a laptop 5 weeks back and now it has a display issue. I want a refund. So as you can see, the message has mentioned the date in weeks. So here we have already mentioned in the function that we need it in this format, year, month and date format, but right now we have given it as 5 weeks back. So as you can see, we have to do something. So we got to update our agent. So next we have to add a code interpreter to deal with date. So let's do that. Okay. So this code enables the agent to execute Python code dynamically by creating a code interpreter action group. As you can see, this is the code interpreter action group. So the process involves 3 key steps. The first one is creating the code interpreter action group. So the function over here, create agent action group, is called to create a new action group named code interpreter action. So an action group defines a set of tasks that an agent can perform, and in this case, it enables the agent to execute Python code using the Amazon Bedrock's code interpreter feature. So now let's just move on to some key parameters over here. As you can see, again, we have the action group name, we have the action group status, agent ID, agent version, which is still in draft. And then we have the parent action group signature, which is Amazon code interpreter. So basically this links this action group to Amazon Bedrock's pre-built code interpreter. This enables the agent to execute Python code dynamically, supporting use cases such as calculations, data analysis, and automation. So why this is important is because Amazon Bedrock provides built-in action groups like this, like for example, Amazon Code Interpreter to handle common AI tasks. So by referencing Amazon.code interpreter, the agent gains the ability to process and run Python code without needing custom Lambda functions. And after that, we are extracting the action group ID over here. So this ID uniquely identifies a newly created code interpreter action group, and it is stored in the code interpreter action group ID for later use. And then we have given a helper function, which is used to pause execution until the action group is fully ready. So the next step is to prepare agent and alias to add new action group. So let's do that. So first let's prepare the agent. Prepare agent response. Agent. Prepare agent. Now let's just, copy the function. The target state is prepared. And let's run this. Okay, there is some error over here. Let me just fix it. As you can see, it is waiting for first, it waited for agent status of prepared. Then finally it has reached the prepared status. Now once that's done, our next step is to update the alias. So let's do that. Bedrock agent update agent alias. We are going to update the alias. Agent ID is equal to agent ID. We have to give the agent alias ID. And we'll keep the agent alias name as test. And once that's done, wait, let me just format it. Yeah, once that's done, let's just paste our helper function. And let's run the code. So as you can see, our agent alias has also been updated and reached the prepared state. So now let's set a session ID and write our message again. So first, let's set the session ID. Session ID strUID. Yes. And we'll rewrite our message. Oh, where was our message? Yeah, this is our message. So let's rewrite this. Let's run it. Now let's write a code which prints its response. I'll write the code first and then get into detail. Invoke agent and print. Again, here we have the agent ID, agent alias ID, input text, which is a message, and the session ID. And here we have given enable trace as true. So we've done it. So basically the invoke agent and print function, it sends a message to the agent and retrieves a response. Again, here we have kept the enable trace as true. So this is the response. We have the agent's thought process, invocation input, again agent's thought process, and finally here we have the final response where it has said that I have reviewed your request and found that you purchased a laptop approximately 5 weeks ago. Since this is within the typical refund period, I have routed your request for a refund to our support team. So they will review the details and get back to you shortly. You can also reference support case. They have also given an ID sort of thing for, our ticket or our case. So as you can see, what it has done is, let's see the agent's thought process. So the agent's thought process was that the purchase search tool found a purchase for this customer that matches the details provided. So now I need to calculate the purchase date to determine if it is within the refund period. So first, to know that, because we haven't given it the correct date, we have given it 5 weeks ago. So to determine if it is within the refund period, it has to, come up with the correct date. So what it has done is, it has actually used the Python REPL to calculate the purchase date from 5 weeks ago, and basically it has calculated the date over here, and then it has come up with the conclusion, the final response, that it is within the typical refund period. Now let's look at another code with another session ID. So we'll give it the same message. Where is the message? Yeah. Next, let's set up the client. Basically, now we want to retrieve the response in streaming format. So for that, first we have to invoke agent response. We have that over here. And next we have to create the event stream. So event stream, invoke agent response completion. So for event, in event stream, if the chunk is in the event, print this, else print this. So this kind of looks cluttered. Let me just format it a bit. So as you can see, what happens here is you already know the invoke agent response and the invoke agent function. Here in this particular part of the code, the loop iterates over the event stream and checks for chunked responses. So if the event contains chunk, like for event contains chunk, the response data is stored in bytes. As you can see in this part, the response data is stored in bytes format, so it must be decoded into a readable string. And the decoded text is formatted as JSON and printed. And for other event types, any metadata or function related events are printed as it is for analysis. So tracing provides insights into how the agent processed the request, and the conversation remains open, allowing continued interaction. So now let's move on to the output. As you can see, this is a pretty big output, so you can take time and see what it is. I will just give you a gist about it. I'll just give you a gist about it. So basically the output represents a trace log of the Amazon Bedrock agent's orchestration process while handling this case. So as you can see, it has all the history, like the agent has been acting as a frontline customer support service, and it has taken requests from a customer named Leah who reported a display issue with a laptop 5 weeks ago. So basically the trace shows the agent's step-by-step reasoning and its function calls, beginning with retrieving customer ID using the provided email, then searching for purchase details using purchase search function which we used, and finally escalating the issue to the support team with the send to support function that we used. So the AI adheres to strict guidelines, ensuring accuracy and compliance by leveraging the Python REPL for date calculations and enforcing guardrails to prevent incorrect assumptions. So it also includes model invocation ports, function calls, API responses, and trace logs, confirming that the request was successfully processed. And as you can see, finally, the agent has also given a final response. Like, I have reviewed Leah's purchase details and routed her refund request to our customer support team. The support team will be in touch with Leah shortly to assist her further with the display issue, so and so. And please let me know if you need any further assistance. So as you can see, the last portion of the output confirms that the response has been finalized and delivered, ensuring smooth AI-driven automation customer support workflows. That was it about this chapter. Now in the next chapter, we will see how to connect this agent to a repository of customer support documents. Hello all, welcome to the next chapter. So in this chapter, we will see how to connect the agent to a repository of customer support documents that discusses simple issues the agent can resolve. So once it is connected, the agent can resolve some issues directly and redirect others to human workflow. So let's start by importing the necessary basic codes and inputs. So the first step, of course, is to run the code to set up the environment. So let's do that. Next, let's import Auto3. Here we also need to import JSON, and let's import the help functions. Next, let's create the client. Bedrock agent is equal to Auto3.client. The service name is Bedrock agent. Region name, we'll keep it as US West 2. Next, let's write the code to retrieve details about the existing agent in Amazon Bedrock. So for that, describe agent response is equal to Bedrock agent dot get agent. Inside, we'll give the agent ID. So basically, the function get agent is used to fetch metadata and configuration details about the specific Bedrock agent. So now let's run the code. For that, let's print the response. So print JSON dumps describe agent response agent is equal to 4 default here that's string. So this is the response. So basically, this code prints the agent details retrieved from the Amazon Bedrock in a structured and a human-readable format. The function JSON dumps over here is used to convert the dictionary stored in describe agent response into a JSON formatted string. So since API responses often return nested data structures, formatting them properly helps in analyzing and debugging the output basically. So the ident is equal to 4 parameter ensures that the JSON output is visually structured with proper spacing, making it easier to read. So without indentation, the response would be printed as a single long line, which is difficult to parse manually. And additionally, default is equal to str is included to handle any non-serializable objects such as timestamps or special data types. So by converting them into strings before printing. So this prevents errors that may occur if the response contains complex data structures that cannot be directly serialized into JSON. So when executed, this command provides a clear view of the agent's configuration, including its name, as you can see, including its name, its status, version, associated action groups, and execution settings. So this output is valuable for verifying whether the agent is correctly set up, checking its state before making modifications, or troubleshooting issues related to its configuration. So by displaying all relevant details in an organized manner, this step simplifies debugging and ensures that the agent is functioning as expected. But as you can see here, they have all the informations, including the instructions. So what we can do is let's take that and print it separately. So for that, we'll write another piece of code, which is print describe agent response agent in instruction. So as you can see, this line of code retrieves and prints the agent's instruction from the API response. So the describe agent response dictionary contains various metadata about the agent, and within it, the agent key holds the main details. The instructions field over here specifically stores the system prompt or predefined guidance that tells the agent how to behave and respond to queries. So as you can see, it has an instruction. First, it has an instruction over here. It has just printed an instruction from the previous output, which is you are a frontline customer support agent for a company and your role is to process customer messages and so and so. And also it has given guidelines for processing customer messages. So first you have to analyze the customer's message to understand their issue. Then you have to determine the appropriate action. You have to use appropriate tools. You have to provide a summary, a clear and concise summary of analysis. And then again, for handling issues based on complexity, there are two types. Like if it's complex issues or those requiring human intervention, or then there are simple issues or general product usage questions. So this is just the instruction printed. So if you go through the output, you'll realize there is lack of knowledge base. Okay, so like they have given the instruction, they have given the guidelines, but still there's a lack of knowledge base. So our next step is to add the knowledge base. So let's do that. Let's write that piece of code. So get knowledge base response agent get knowledge base. Sorry. Knowledge base ID is equal to knowledge base ID. So as you can see, this code retrieves information about a knowledge base linked to the Amazon Bedrock agent. So knowledge base is basically a collection of stored informations like FAQs or company guidelines that the agent can use to give better responses. So this function over here, get knowledge base of, is called with knowledge base ID, which ensures that the correct knowledge base is assessed. The response is then stored in the get knowledge based response, which contains details such as knowledge base name, status, description, and stored documents. So running this function helps check if the knowledge base exists, is it active and properly linked to the agent. So this is useful for troubleshooting cases where the agent is supposed to retrieve information but isn't responding quickly. So now let's just print this and see. Print JSON dumps get knowledge base response. Intent is 4. So as you can see, we have printed and the response contains a lot of configuration. Now next, let's connect this knowledge base with our agent. So to do that, first let's type the code and then we'll see how it works. Associate agent base response is equal to drop agent associate agent knowledge base. We have to provide the agent ID, the knowledge base ID, the agent version, which is draft, and the description, which is my knowledge base. We'll give it as my KB. Just format this a bit. So as you can see, this code links a knowledge base to an Amazon Bedrock agent, allowing the agent to use stored information when generating responses. So the function over here, which is associate agent knowledge base, connects a specified knowledge base with knowledge base ID to the given agent ID. And here the agent version is draft, which ensures that the change applies to the agent's draft version before being finalized. And the description, we had given it as myKB, which provides a short reference name for the knowledge base association. So basically, this function allows the agent to access and reference information from the knowledge base when answering queries. And by running this, you ensure that the agent can retrieve stored knowledge, improving accuracy and response quality. And it is useful for customer support, FAQs, and structured document retrieval. Now let's just look at the output. Associate agent knowledge base response. So as you can see, the knowledge base is enabled and we are ready to go. Now next, let's prepare the agent and alias. So I will just take the code and paste it because we have done this multiple times by now. Now let's see the code. So basically, this code prepares the agent for use, updates its alias, and ensures everything is fully activated before proceeding. So it consists of 4 key steps. I'll explain it to you again. So the first function, which is prepare agent, is called with agent ID, instructing Amazon Bedrock to process and activate the latest changes made to the agent, such as updated actions on a newly linked knowledge base. Waiting for the agent to be ready. So since the preparation process takes time, wait for agent status function ensures that the agent reaches the prepared state before moving forward. And this prevents errors from calling an agent that isn't fully activated. And the next one is updating the agent alias. So since the preparation takes time, so the function update agent alias assigns a new alias, like my agent alias, to the agent. So an alias is a version reference that allows different agent versions to be accessed in a structured way. And this step ensures that the alias is correctly linked to the updated agent. And finally, waiting for the alias activation. So wait for agent alias status function ensures that the alias is fully prepared before use. And this guarantees that any request made to the agent will work correctly. So these steps finalize all updates and ensures that the agent is fully functional before invocation. And this approach prevents errors, incomplete updates, or unresponsive behavior, making the agent reliable and ready to process queries. So let's just run this code. Let's wait for it to process. So once it's executed, you can see that we have a fully built customer support agent by now. So now let's just ask it some questions to see how it works. So first, let's give the session ID and our message. Again, we have given this multiple times by now. Creating a session ID. Message is leah@leah.com. I bought a laptop 5 weeks ago and now it has display issues. I want a refund. Now let's give the invoke agent function to print. Here we have disabled the trace. Let's print it. So it has actually given us a response saying that I've reviewed a request for a refund on the laptop you purchased about 5 weeks ago, and that is now having display issues. So I was able to look up the details of your purchase using the information. Based on my research, I've escalated your case to our customer support team for further assistance. So a support agent will get in touch. So you can, continue asking more questions. Like for example, let's try another message. It says, Let's ask, I am unable to connect my laptop Wi-Fi. What can I do? And let's print this. So we have enabled trace. So as you can see, this is the output, and the guardrail trace is none. It has given the agent's thought process like, okay, let me see how I can assist you with the issue of not being able to connect your laptop to Wi-Fi. And then it has gone to the knowledge base. And then it has come up with a final response, like to troubleshoot the issue of not being able to connect your laptop to Wi-Fi. Here are some steps you can try. And it is given to 5 steps. So similarly, you can prompt more questions and see the response, how the agent responds to your queries. So basically, the agent is now designed to follow the conversation flow and use agentic reasoning to decide how to handle each customer request. And it doesn't just respond blindly, as you have seen. It analyzes the situation and figures out the best course of action. So what makes this agent powerful is its ability to take different paths depending on the problem. So if it's a simple issue, it can resolve it on its own, but when a situation requires human assistance, it knows when to escalate to a support agent. So the way it makes these decisions come down to 3 things. Number 1, the agentic workflow that guides its decision making. Number 2, the instructions we provide to shape its behavior. And the third one, the tools and actions it has access to, like knowledge bases and APIs that you have seen in this example. So together, these elements allow the agent to be efficient, adaptable, and capable of handling a variety of customer interactions smoothly. So that was it. In the next chapter, I will give you a quick walkthrough of the Amazon Bedrock console. So now that we have successfully built a customer support agent using code, it's important to explore how the Amazon Bedrock console provides a visual and interactive way to configure AI models, manage agents, and fine-tune various functionalities such as guardrails and knowledge bases. So while coding provides greater flexibility and control, the console simplifies the process by offering an intuitive interface that allows for quick modifications, testing, and troubleshooting. So Amazon Bedrock is a part of AWS Serverless AI infrastructure, which means it can integrate seamlessly with other AWS services while giving users access to pre-trained AI models from multiple providers. So this makes it an ideal tool for companies and developers looking to build and deploy AI-powered solutions without the need for extensive machine learning expertise. So to access Amazon's Bedrock, you first need to log into your AWS account, and once logged in, you have to navigate to the search bar and search for Bedrock and select Amazon Bedrock from the search results. So as you can see on the left-hand menu, you'll see several options that allow you to explore the different components of Bedrock. So these options include model providers, agent management, guardrails, knowledge bases, and playgrounds for testing AI models interactively. So by providing a centralized dashboard, the Bedrock console allows users to easily manage AI-driven workflows, configure the AI assistant's behavior, and enhance their knowledge retrieval capabilities. So one of the most important aspects of Amazon Bedrock is a variety of AI models it provides access to. So Bedrock allows users to choose from models built by leading AI research organizations, offering a range of capabilities such as text generation, reasoning, summarization, and question answering. So as you can see inside the console, the providers section lists the various AI models available in Amazon Bedrock. So some of these include the Amazon AI, Anthropic, Claude models, AI21 Labs, Cohere, Meta, Mistral AI, Stability AI, etc. So as you can see, each of these providers offers different types of large language models, which can be used depending on the specific requirements of a project. Like for example, Anthropic's Claude models are known for their safety-first approach, while Meta's Llama models are designed for high-efficiency reasoning tasks. So if you encounter errors when you are trying to use these certain models, it is likely because they have not been enabled for your AWS region or account. So the Bedrock console allows users to manually enable access to these models by navigating to the model access settings. So here users can agree to end user license agreements to enable specific models, modify access permissions to allow Bedrock to integrate with those models, and select or deselect models based on their respective project needs. So once a model is enabled, it becomes available for use within agents, knowledge bases, and other AI-driven applications. So first, let's have a look at agents for configuring and managing AI assistants. So one of the most powerful features of Amazon Bedrock is its ability to create AI-powered agents that can interact with users, process queries, and provide intelligent responses based on available data. So the agents section in the console provides tools for managing the assistants. So when you open the agent section, you will see a list of existing agents along with their current status. So these agents can be in different states, as we have already seen while coding. So it can be in the prepared state, which means it is ready to use and actively responding to queries. And it can also be in not prepared state, which means that the agent has been created, but it isn't fully configured yet. So to create a new agent, users can click the create agent, enter a name. You'll be having an option to enter a name, a description, and also select the large language model that will power the agent's response. So this step is crucial as the model selection determines the quality, response style, and processing capabilities of the agent. So basically, the agent builder provides a structured interface where users can define detailed agent instructions, choose best suited AI model, enable the code interpreter, which allows the agent to execute Python scripts when needed and customize its workflow and processing logic to suit business requirements. Now, a major part of setting up an agent involves configuring action groups, which define what the agent can actually do. So action groups allow the agent to connect with external tools, databases, and services to perform tasks beyond simple conversation. So within the console, users can link agents to external services using AWS Lambda functions. Amazon Bedrock simplifies the process by providing a quick create Lambda function option, which automatically generates sample Lambda code, configures the necessary AWS permissions for execution, and allows developers to customize Lambda functions for business-specific use cases. So for example, if a support agent needs to retrieve a customer order details, an action group can be set up to query a database through a Lambda function. So once the function is triggered, the response is processed by agent and delivered back to the user. And also after configuring an agent, the console provides an interactive test environment, allowing users to send sample queries, debug unexpected agent behavior, and ensure proper integration with external systems. Now next over here, we have the guardrails for controlling and filtering AI responses. So AI safety and compliance are critical when deploying automated assistants. So Amazon Bedrock offers guardrails, which we already saw while coding in a previous chapter, which allows users to filter and control an agent's responses to ensure it behaves within set guidelines. So as you can see, unlike action groups, which define what an agent can do, guardrails define what it shouldn't do. So these settings block inappropriate, harmful, or restricted content from being generated. So the console makes it easy to set up and manage guardrails through an intuitive interface, allowing users to specify denied topics that the agent should avoid, define content filters to block inappropriate responses, and adjust AI safety levels using interactive sliders. So for example, if an organization wants to prevent an AI assistant from providing financial advice, a denied topic can be configured within the guardrail settings. And then there is knowledge bases, which is for expanding the agent's knowledge. So basically, knowledge base enhances an AI agent's ability to provide accurate and informed responses by allowing it to access structured data. So this is particularly useful for customer support, internal documentation, and FAQ systems. So the console simplifies knowledge base creation by guiding users through entering a name and description for the knowledge base, setting up access permissions, and choosing a data source such as Amazon S3, Salesforce, SharePoint, or a web crawler. So once a knowledge base is set up, the data needs to be indexed in a vector base to enable fast and efficient retrieval. So Amazon Bedrock supports multiple vector storage options like Amazon OpenSearch, Serverless, Aurora PostgreSQL, MongoDB, LTAS, and Pinecone. So when users queries the agent, the system retrieves relevant information from the knowledge base and integrates it into the agent's response. So the Amazon Bedrock console provides a comprehensive interface for managing AI agents, configuring workflows, and integrating data sources. While coding gives developers full control over implementation, the console simplifies deployment, testing, and fine-tuning, making it accessible for both technical as well as non-technical users. So by using all this AI model customization, guardrails for safety, and knowledge bases for enhanced understanding, Bedrock ensures that AI-powered solutions remain accurate, efficient, and aligned with the current business needs. So that was it. Congratulations on completing the Introduction to Agentic Workflow course from Simplilearn. Throughout this course, we explored key concepts of agentic workflows and how they can enhance automation. We learned how to create an agent using Amazon Bedrock connected with the CRM, to perform calculations and read an FAQ manual for different information retrieval. We also walked through the Amazon Bedrock console, giving you a hands-on understanding of its features. So with these foundational skills, you are now equipped to build intelligent, automated workflows that streamline business processes. So keep practicing, stay curious, and continue exploring the possibilities of AI-driven automation. Thanks for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.